Come on. Where's that cursor? All right, so inverse trigonometry. From yesterday, do you remember where you can trust a calculator? That's about it. The first 3 or 4 slides are literally to show you how your calculator's programmed to return answers. You don't have to write out anything down here. But when you press the arc sine function on TI-84, it only returns angles that lie between negative 90 and positive 90 degrees. That's what it was programmed to do. That's all it can do. So a TI-84 only returns angles that lie somewhere between quadrant 1 and quadrant 4. Because this would be 90 degrees, wouldn't it? And this would be negative 90 degrees of rotation. So it's only returning quadrants, angles in quadrant 1 and 4. That's all it does. That's why you can't trust it in the other quadrants. Our cosine on a TI-84 is programmed to return angles that lie between 0 and 180 degrees. What 2 quadrants cover 0 to 180 degrees? 1 and 2. Because all angles start here, and then they rotate to a terminal side. So it only works in quadrants 1 and 2. That's it. And the last arc function, arctangent. Arctangent is very similar to arcsine. It returns angles that lie between negative 90 and 90, not inclusive. Notice there's no equality. What you got, Tim? Huh? Negative 90 and 90? Yeah. What's there? Quadrants 1 and what? 4. That's how the TI-84 is programmed, kids. That's why you can only trust in quadrant 1. It'd be nice if arc cosine worked like arcsine and arctangent. It's the oddball, isn't it? Arctangent works in 1 and 4, arcsine works in 1 and 4. Not arc cosine, it's 1 and 2. If you take me for pre-calc, we will actually talk about why it is that way. Here is ASTC, and I wish, but I'm recording, I can't say the R-rated version of this. Your acronym will be All Schools Torture Children. ASTC, All Schools Torture Children. That's to help you remember it. ASTC tells you the trig ratio sign in any given quadrant. So in the first quadrant, all the trig ratios are positive. Doesn't matter if it's sine, cosine, cosecant, secant. The ratio is going to be what? Positive. Second one, sine and cosecant. What's the relationship between sine and cosecant? What are they to each other? Flips. They call that reciprocals. They are positive. If sine and cosecant are the only thing positive in quadrant 2, what's that mean about the other 4 guys? There's 6 trig ratios. If these 2 are positive, the other 4 are negative. Quadrant 3, you got a T for tangent, and its reciprocal cotangent. They are positive. What's that mean about the other 4? They're negative. Finally, in quadrant 4 is C. C stands for cosine and its reciprocal secant. They are positive. What's that mean about the other 4? They are negative. Here's why that matters. These questions have 2 answers. How many answers is your calculator capable of returning to you? 1. That's why that matters. Now, every one of you can push buttons in a TI-84 and see what the arc sine of root 3 over 2 is. Or you can just sit there. Whatever. And second sine. Miss Cantrell called it inverse sine. Second sine, root 3 over 2, should be, I think it's 60 degrees, but I'm pretty tired. It is 60. If you're not getting 60, what's wrong with your TI-84? The radian level. All right, we're going to leave everything in degree levels. We're always going to take a radian and convert to degrees. We're not ever going to change in the radian level. Always going to work with degrees. So that's 60 degrees. That's only one answer, though. The reason that ASTC is a pretty big deal, notice what it says up here. Find all angles. That's implying there's more than one, doesn't it? Such that the angle lies between 0 and 360. Here's why ASTC is important. That ratio is positive. It's the sine ratio. By ASTC, what two quadrants is the sine ratio positive? 1 and 2. A stands for all. A lot of kids don't get this because they never write. S stands for sine. If you want to know where it's positive, you're going to be here, and you're going to be here. Calculator gave you a 60-degree angle. That's a perfectly acceptable answer because of how angles are drawn. Angles are drawn starting where? Not the origin. Positive x-axis. You don't rotate on the origin, you rotate around the x-axis. That's a perfectly acceptable answer. That's a fine angle. So that's correct. Sine gets to be positive in quadrant 2. Now, yesterday's lesson mentioned that most of the time these angles that are returned get to be used as what kind of angles? Reference angles. They get to be used as reference angles for the most part. Sometimes our cosine will mess you up, but they get to be used as reference angles. So I can take and I can draw a reference angle in quadrant 2 that measures how many degrees? 60. Reference angle again is formed with the closest x-axis and the terminal side of the angle. You do it on the same one, I just know it gets cluttered. It gets really cluttered if you do it all on the same height. Is that the measure of that angle? No, angles start on what axis? Positive x-axis, and then they rotate to the terminal side. The angle starts here, rotates there. 120, that's right. 180, you got a straight angle, don't you? 60 is known. That's geometry when things were easy, wasn't it? That's 180 minus 60. 120. All right, now what's it say up top? It says radians and degrees. You got more work to do. You're going to see me use notation here like theta 1 and theta 2. We have two angles, don't we? So theta 1 was 60 degrees. How do you convert that into a pi array? Remember, you guys got a formula quiz tomorrow. You're supposed to know how to convert from a radian into a degree, and vice versa. Multiply pi by over 180. If you are incapable of doing this in your head, how do you do this in a calculator? Don't use pi. You don't use pi. This was the lesson we had on Friday before we left for spring break. You do 60 parentheses 1 over 180. And for the bajillionth time in my career, how do you convert a decimal to a fraction? Math enter, enter. Got 1 over 3. What's the 1 going to become? Pi. One of your answers would be pi over 3. The other answer that we came up was that the second angle measured 120 degrees. And you can push the buttons together if you want, but you don't have to. It's twice 60, isn't it? So it's going to be twice pi over 3. Twice pi over 3. It's 2 times a pi over 3. God, Americans suck with fractions. 2 pi over 3, kids. If you put a 2 in front of that thing, it's 2 pi over 3. 120 is twice 60. Double the radian, you'll be in good shape. All right, what question do you need to ask about that? Big thing here is drawing. A lot of kids don't want to draw. And you need to at least understand you can't trust a calculator, can you? It'll be half right at best. At best, it's going to be right half the time. Now, here's how you check your work. If 60 degrees is an answer, if the arc sine of root 3 over 2 is 60 degrees, then sine of 60 is going to be root 3 over 2. That's how it works, those are inverse functions. And we're not going to worry about your radian measure. We're going to worry about things you found in degrees. I know the 60 degrees is going to be right because the calculator told me that in the first place. But the sine of 60 is 0.8660. That's what it is. Guess what a root 3 over 2 is? The same thing. What was our other answer? 120, wasn't it? What should the sine of 120 be equal to? Root 3 over 2. This is the one thing the calculator can do right. It can help you cheat on a multiple choice test. So if I ask you what the arc sine of something is, and you know there's two answers, you can just use the sine function on the answer choices and look for whatever that ratio is. They're the same thing. B is the arc cosine of root 2 over 2, and the first question that's asked is where is cosine positive? Because that's a positive number. What quadrants? By ASTC. Not 1 and 2. Nope. 1 and 4. A is for all. C is for what? Cosine and secant. 1 and 4. That's where cosine is positive. See what your calculator says the arc cosine of root 2 over 2 is. See what the calculator says arc cosine of root 2 over 2 is. That's what's on the paper, isn't it, bro? 45 degrees. I memorized that when I was 17. 45 degrees. Is that an angle you can keep? Is it in quadrant 1? Is it an angle you can trust? You can always trust an angle that lies where? Quadrant 1. Where else do you have to draw a 45-degree reference angle? Quadrant 4. The other location cosine can be positive. So you can draw the reference angle of 45 degrees. Then you have to think about how angles are supposed to be drawn. For probably the 5th time today, when you draw an angle, on what axis do you start? Positive X. And then you rotate. You start there and you rotate here. That outside rotation is the angle. How many degrees is it? How many degrees in a full circle, kids? 360. You covered all but 45, didn't you? 315. So we found one answer to be 45 degrees. We found another one to be 315. Let's check them. Make sure they work. I wouldn't press sine of 45 degrees here, check it. What would I have to press? I want to check it. What do I press? This is arc cosine, right? If the arc cosine of root 2 over 2 is 45, then the cosine of 45 should be what? Backwards operation, kids. Shouldn't it be root 2 over 2? Should be root 2 over 2. So cosine 45, the first one will be right for sure. Calculator gave you that one. That's that funky looking decimal. The second answer was 315. It should match, shouldn't it? It does. And then lastly, you probably want to see what root 2 over 2 is. Well, I would hope. I memorized that in algebra 2. Same thing. That's how you check your work. All right. What do we got left on here? An arc tangent. And we're going to do one that's a little bit different. There we go. Arc tangent negative root 3. The instruction set changed just a little bit here. You got this little thing up there for 0 pi to 2 pi. What does that mean? Convert into degrees. What's 0 pi in degrees? 0. That's 0 degrees. About twice pi. 360, because pi is 180 degrees. Somebody asked you to memorize that. So you're looking for answers that lie between 0 and 360 degrees. Guess how many there's going to be? 2. 2. Not 4. All right. In what two quadrants is the tangent ratio negative? Don't you dare say 1 and 3.
32.
It can't be 3.
4 and 2.
Why can't it be 3? Because there's a t there. That means you're what? Positive. Why can't you be quadrant 1? Everything's there. You got to be 2 and 4. In 2, sine and cosecant are positive. Everything else is negative. In 4, cosine and secant are positive. Everything else is negative. The calculator is going to return an answer that lies in quadrant 4 because it is designed to return answers in quadrants 1 and 4. See what your TI-84 says the arc tangent of negative root 3 gives. All right, it says negative 60 degrees. On a multiple choice test, are you going to pick that answer? You probably are. Should you? Why not? What does the angle have to lie between? 0 and 360. It can't be negative 60. So you can't directly use the answer, but you can draw it, can't you? You want to know what well, a lot of kids did not do the drawing homework. You're going to rotate like a clock. You don't have to put negative 60 there. Rotation implies negativity. You're going to rotate like a clock. Now, how do you make it positive? Make it positive, how do you rotate? Counterclockwise, that's right answer. All angles positively rotate counterclockwise. How many degrees of positive rotation actually happen? 300. That, by the way, was coterminality. Those angles have the same terminal side. So that one's gone. You got an answer of 300 degrees. There's another answer. That wasn't the second answer, that was the first answer. The second answer lies in what quadrant? 2. The other one we circled. You get to draw part of an angle in quadrant 2. You get to draw the stuff left over. What's the stuff left over? Calculators return things that can be used as reference angles. 60. A little piece is 60. What's the big piece?
3.
Oh, that's the big piece. The big piece starts on the positive x-axis and rotates to the terminal side. 120, that's right. Here's your other answer. 120. How many degrees in a straight angle, Tim? 180.
I know that.
Well,
That's why I said 120.
okay. I thought you said you didn't know. There's kids who don't. A lot of kids that don't know how many degrees in a straight angle. So, one of your answers was 300. What do you have to convert it into? A pi rad, how? Pi over 180. Again, if you're going to push buttons, just don't put a pi symbol in there. Probably memorize them quicker if you did it by hand. It might take you longer initially. See, when you use a calculator, you don't have to think, so you don't memorize. Here's 5/3 what? On pi. You're a big man, don't forget about pi. Somebody puts a pi in front of me, I'm not forgetting about that pi. The other one's 120 degrees, we've already done that one today. That's 120 is pi right. 2 pi over 3. So there was a situation where you couldn't trust your calculator at all, could you? The answer it gave you in the first place was not even acceptable. It had to be thought about. That's probably why a lot of kids don't like the arc functions. They just want to push buttons and be done with it. Critical errors, you think. SOHCAHTOA is just the very first thing in trigonometry. It's like learning the first 5 letters of the alphabet. It really doesn't get you a whole lot. Not much you do with the first 5 letters of the alphabet, is there? Can you even spell anything with the first letters? I guess you can spell cab. I'm sure there's a couple of words you can spell, but there's not much. This is quadrantal angles. Your calculator can do some of this, and it will actually get it right about 2/3 of the time. Why don't you go ahead and press buttons in your calculator to see what the arc sine of 1 is. 90 degrees. It better be 90 degrees. Anybody know why? Sine ratio is opposite over hypotenuse. This is something you hardly ever do. But if you're sitting at the right angle, say that's angle A, and you want to find the sine of angle A, and you do opposite over hypotenuse, say I put a hypotenuse up there of 5, this is an example. If you're opposite, what's your length? What's opposite of angle A? 5. And that would sit over the hypotenuse, which also happens to be 5. That's why we're turning 90 degrees. Should. Dealing with the right angle. Change the second one to cosine of 0. See what your calculator says. That's the one it missed. There's 2 answers on this one. Change the third one to arc sine of 0. It says 0. They missed that one too. Now these are called quadrantal angles because of where they lie. 90 degrees lies in between quadrants, doesn't it? 0 degrees lies in between quadrants, doesn't it? Those are called quadrantals. To do these properly, you don't really use a calculator. To do these properly, you take a circular approach. Remember us talking about a circular approach to trigonometry? Simply, you take a unit circle approach. It's the only way to properly do them. This calculator is going to lie on them. It's not going to get them right every single time. So to do these properly, do a unit circle. So I have a unit circle in front of you. Unit, by the way, means 1. Always has, always will. You see the word unit, it means 1. There's 4 really easy points to pick out on a unit circle. Here, 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 and here. Each of those points has an ordered pair associated with them. What's the ordered pair right here? 1, 0. You went right 1, up nothing. What's the ordered pair up there? 0, 1. At 180 degrees. At 270 degrees. 0, -1. You understand why I said like 180 degrees, 270? Yeah, I was talking about rotation, wasn't it? That's what I was talking about. All right, now from the circular approach, if you take the circular approach, which we did yesterday, how do you find y, or sorry, how do you find sine on a circular approach? This is yesterday's lesson. The sine of an angle, circular approach. Psi, as in sine, rhymes with y, doesn't it? On a circular approach, the sine ratio is y over what? Not x, r. On a circular approach, cosine is x over r, and on a circular approach, tangent is y over x. Now, if I'm talking about the unit circle, what are those radiuses? No, they're 1, aren't they? This becomes y over 1, which is just y. X over 1, which is just x. Tangent doesn't change. This is a unit circle approach. Now, when you talk about arc sine of 1, what you're actually saying is where is the sine ratio of 1? That's what you're actually asking. Where is that sine ratio 1? And on a unit circle, sine is what coordinate? We reduce sine of theta all the way down to what? Y. Psi, y. On a unit circle, where is the y value 1? How many degrees? Right there. That's 90 degrees of rotation. That's why your calculator said 90. Is there any other place on the unit circle where the y value is 1? None. Now, I told you your calculator only told you half truth on the second one that we changed, by the way. Calculator told you 90 degrees. It's talking about our cosine. That is asking where the cosine ratio is what? 0. That's what it says. You're supposed to find where cosine ratio is equal to 0. There's two places on a unit circle where cosine is 0. Because cosine, by the way, is what coordinate? X. One of the places was the answer the calculator gave you. Where's the other answer? Way down here, where x is 0. Talk about rotation. Alex told me it was 270. For those of you that don't see it, that's the rotation. 3 quadrants rotation. 270 degrees. That's the answer your calculator can't tell you. It's not allowed to. Go back and look at your notes. The calculator can only return angles that lie in quadrants 1 and 2 or anywhere in between. It will not return an answer down there for our cosine. Let's see here. I changed the third one to be the arc sine of 0. What's that asking? Look at the previous examples, kids. That's what that one's asking. That's what that one's asking. This one's got to be about sine, isn't it? Where is sine, which is y, equal to 0? That doesn't have one answer. It has two. This is the one the calculator returned, isn't it? 0 degrees, no rotation happened. The angle never moved, did it? It started at the x-axis, and where did it stop? start and stop. No rotation, 0 degrees rotation. The other one is how many degrees of rotation? Right there. How many degrees of rotation is that? 180. And I also know how y'all feel about this, because I know what happens if we gain dispersive bias. That's why that lesson about drawing angles is so important. It was a very important lesson on how to draw angles. Yeah, I guess we'll do a little more. Get one more slide up, y'all. Solve the equation for theta. This actually isn't that much different than what we've been doing. It says the tangent of theta is 1. I probably got this all written out. The question is asking what angle has a tangent ratio of 1. How do you do that in the calculator? If the tangent of theta is 1, how do you find theta? You guys even take geometry off your phone. I showed you this Thursday before break. Tangent of theta is 1. To free up theta, you have to do the opposite action. What's the opposite of tangent? Arctangent. You have to do the inverse operation. So, see what your TI-84 says about the arctangent of 1. I know what you'll say. Yeah, $100, she says 45 degrees. That's what memorization gives you. It gives you speed and clarity. That's why you should be memorizing. A lot of y'all didn't push a button. Can't even give yourself a chance. Calculators say 45 degrees. Now, this one's got some other stuff. It has this little thing off the side that says sine of theta is less than 0. What's that mean about the sine ratio? It's less than 0. If something's less than 0, what does that mean? It's negative. So that little disclaimer off the side is saying, where is the sine ratio negative? There's a little more to it, too. The tangent ratio was 1. It was a positive 1. So in addition to knowing where the sine ratio is negative, you also have to know where this tangent ratio is what? Positive. So let's start there. What two quadrants is a tangent ratio positive? Not 1 and 2. A and T. A for all, T for tangent. It's probably circling. Now, the other part is where is the sine ratio negative? Three and 4, that's right. Which quadrant satisfies both? 3. Your calculator told you 45 degrees. That's what it told you. 45 degrees is not in quadrant 3. 45 degrees is in quadrant 1, isn't it? Quadrant's 9 degrees. So what can you draw in quadrant 3? Calculators return what kind of angles? Reference angles. What can you draw in quadrant 3? Even though your answer can't be, you draw a 45 degree angle in quadrant 3. An angle formed with the x-axis. A lot of kids like to form these angles with the y-axis. It's about the x-axis. You can put 45 degrees there. And then you can figure out the actual answer. What's the actual answer? What's that? That's right, you get from 225. You start here, stop there. 225 degrees of actual positive rotation. What else should you probably do with that answer? Make it a pi rad. I hate that for you, but it's your standard. You're supposed to understand pi rads. How do you convert a degree into a pi rad? Pi over 180. You're supposed to learn enough trig in Algebra 2 that when you walk into a trigonometry class, you can do some of it. At least the basic building blocks. 225 is pi rad. Pi over 4? There you go. Don't forget about pi. And that has probably cooked most of y'all's brains, so I'm done for now. I'll finish off the job tomorrow. Welcome to Trig. If you still want to be an engineer,